Thanks, Isu. So before we go to the main content, so I just want to give a brief introduction about how data has evolved in the past, not recent actually, from the ancient time, how the data has evolved and how the importance to store the data has been in the evolution of humankind. So you can see even from the ancient time, humankind had the need to store data, right? We all know that from the ancient time they have been storing data in kind of stones. They have written the some data in the stones, or they have written on the walls of the caves. So the purpose is they wanted to pass the message to someone, right? They wanted to store the data. So that was a essential need even in the ancient times, right? So that has been evolved, and actually 10 to 5,000 years ago, we have started actual data record in the form of papers or something, right? So after that, it has been moved to the digital data record, right? Now actually we are in the era of recording data to the purpose of AI, right? So that's where we are now. So data is very essential. We can't avoid data. Data is very much connected in our day-to-day life, right? So moving on, in the industry of IT and infrastructure, so we all know how data is important, right? So before 2000, actually there have been so many kinds of databases, right? So we had direct databases and we stored data, right? After that, like in the year of 2006, the big data came into picture, which means massive amount of data, right? So when AI started to emerge, the need for the data increased drastically, very much, right? So from that, 2020s, AI applications started developing, Gen AI, the models have started developing. So as more as there is AI application, there is a massive data stored behind in some sort of an infrastructure data center, right? So that is the importance for the data center in the era of AI, right? So in terms of when we consider data centers, right, just storing data is not the thing. Data has to be secure, right? Plus scalability, manageability. Those are few key things when it comes to a kind of a modern data center that we need to consider, right? So moving on, as I mentioned earlier, AI adaptation is one of the key things, right? So as I mentioned, now AI is that it's not something come from nowhere, right? So there has to be some data fed into a system, right? So for that, actually, now not only CPU data, there are GPU, NPU, resource utilization. So there has to be a massive infrastructure. So the second thing is new services. Now, if you take the industries like banking or the manufacturing industries, so many new services being adapted, right? So for that, there has to be, like, if you take the banking services, you can see the transactions, how many transactions per day is generated, right? So the growth is very high. So the third thing is data resilience. As long as we maintain the data, it has to be secure. We have to make sure the data is secure without affecting by any ransomware attacks or viruses. Or there are so many kinds of insecurities that can cause harm to a data center, right? We have to consider that. Then the sustainability. In terms of maintaining a data center, also we have to have a data center facility, including ecosystem, power consumption, all these things we have to consider. So these are few key important things that we have to consider when we are building a resilient data center, right? So let me come to this quickly, right? So earlier we had traditional data centers, like we had traditional computing architectures. Then behind that we had traditional data storage architectures, which built with siloed architectures. There will be IT resources in the data center. Then the power will be provided from a separate system. So it's kind of a traditional setup. Then the hyperconverged and converged data center architecture came into picture, where all these computing and these resources were combined, right? And even including the data center facilities like cooling, everything came into picture. So moving on, now actually we focus on compressible distributed infrastructure, which means it's like a data resource pool, where you have all these computing, GPU, storage, all these resources as a resource pool for big data and data analytics and AI application purposes, where you can get the resources as far as it is required. So that is the concept now in the modern age of data centers, right? So that's all actually I wanted to highlight. So two takeaways just I wanted to mention. Now, if you consider AI, right, I would say that AI is never equal to human, right? For two simple reasons. One is, as I mentioned earlier, there has to be human data to generate AI, right? Without human data, there will be no AI, because AI robots or AI machines, they can't generate their own data, right? The second thing is, if you take, you are using AI applications, it can be ChatGPT, DeepSeek, or anything, but you all don't know how much of an infrastructure that is maintained behind to sustain all this data to give the result that you get in the AI application. So if you take companies like Google or Huawei or AWS, they are maintaining massive landscapes to maintain their data centers that we don't see, right? But human, we know that our small brain can contain all this data, right, which is trained from our infant age, that is trained. So we maintain all this within a small brain, but that is not possible when it comes to AI. So with that note, I would like to hand over to our expert. So he will more focus on data center resilience, right? So let's make it as a discussion. So if you are having questions, you can ask, and we'll have some interesting Q&A sessions as well. So over to you.
Good morning. Morning, everyone. My name is Wang Yujue. I'm the data center architect from the Huawei Asia Pacific. I overlook the entire region in terms of the overall full stack data center design. Okay, covering mainly from the cloud platform and the virtualization platform. So if you have a gist about data center, you understand when we talk about platform in the data center, normally there's something to the north, talking about application services, and also something to the south about managing all the hardware devices in the data center, right? So basically what I'm doing is I'm building the modern data centers for various industries across Asia Pacific, and with a focus on the cloudification and containerization and virtualization, so on and so forth. Okay, so today, as my colleague has mentioned, we are going to talk about resilience of data center. Okay, everyone knows about data center. We're not here to tell you what is the data center, what is the importance of data center. I think everyone has this idea somehow. We're here to talk about resilience. How you can build your data center that is resilient to disasters, to human errors, to securities, to, for example, the hacker attacks, ransomware attacks, so on and so forth. Okay, so without further ado, I will start. So this is basically, I'm here giving an overview of the white paper. I'm not sure how many of you have already get this white paper downloaded, because this is completely published. While we publish this one, we try to jointly publish with a very renowned bank in China, try to set an industry standard. Whenever for everyone globally, when you build a data center, maybe you should follow the procedures and frameworks inside this one. So we will go through this one. Okay, and as my colleague has mentioned, so AI fuels the needs of the data center. Okay, so remember that's a time when we talk about maybe 20 years ago, 10 years ago, when we build a data center. Normally, it's not that much of a big thing, right? Every organization or like enterprise have like a server rooms or something holding some servers, some computers, some switches, supporting the daily usage of your enterprise IT, right? But now after this emergence of AI, the data centers are now becoming the core production engine for the society, right? People are like realizing we have to build this one as an infrastructure, no longer as a service portal to support a single organization's daily functions, but to as the engine for the society, the engine for the organization for the future, right? It's a future forwarding idea over here. So with that being said, basically I will use 4 chapters. So this is, as I mentioned, the overview of the white paper. We will go through them slowly one by one. Okay, and feel free to have interaction with me because to be honest, I'm not sure about all the backgrounds of the audience here, how much you have been getting depth with the data center, what I am, and data center architecture. But now, don't worry about that, okay? We can talk about something in depth, also something maybe more in general. Just feel free to interact with me, okay? Let's try to make this fruitful, okay? So chapter 1, strategic positioning and the values of DCs in the intelligent world. Okay, what do we mean here? It's a new mission, like I mentioned. From supporting role to data center stage, to center stage in digitalization. This is what I mentioned for data centers. Previously, it was a supporting role, just like to support, as I mentioned, enterprise IT. And now it's the center of digitalization. So if you heard about this, the general increase in terms of computing power worldwide, okay, when we talk about computing power, either it's a general purpose computing, those CPU powers, or the GPU from the intelligent computing. Everyone, from the nationwide, every country, and from those internet companies, tech giants, they're like having this arm race in terms of building data centers and having those GPU and computing powers inside the powerhouse to support the AI. Either it's a training or it's an inference, okay? So with the rapid advancement of AI, DCs has transformed from traditional IT infrastructure to an engine for enterprise digital and intelligent innovation. This is the very first idea I would like to ingest to your brain, all right? And there's 3 changes in generally speaking. So first of all is the investment. So if we're talking about building a data center now, that's a larger portion of the investment, or let's say the budget, from building a data center overall towards the IT infrastructure. Traditionally was more towards the facility. Okay, by DC facility, anyone has any idea what is the difference between data center facility and IT infrastructure? Okay, so very small question. Number 1, anyone has idea? You have idea what is the difference between the data center facility and IT infrastructure within the data center? Okay, I give you the answer. DC facility, we're mentioning about those facility like cabinets, racks, okay, power units, cooling system, namely the AC or chiller, and the foundation, maybe the building itself that hosts the room for the data center. So those are more towards what you can treat as civil engineering. Okay, there's some technology within, but not that much. Okay, but normally those parts consumes a large portion of the budget. Why is that? Because it's about civil engineering. You have to actually build a building, put the data center racks all inside, and do the lighting, do the air conditioning, so on and so forth. So previously was you spend larger portion of that on those kind of facilities, and nowadays you actually spend 60%. Okay, 6% of raw budget to the IT infrastructure. So the actual devices, the smart things, the computers that you put inside, namely the servers. Okay, within the servers you put either CPU or GPU, right, for the computing, and you have network switches. Okay, also for those switches to form the communication between different server nodes, you have to have communication and networks, and then storage. Okay, if we recall what we learned from either the high school or in the middle school, when we talk about computer, what are the 3 major like components, or the most important components if you are talking about computers. Right? We need CPU, which is compute, right? And then we need network. With network, we can interact. And third one is the storage. There's some data generated and we need to store them. It's the same in the data center, just like our computers. These three major components. So now those are what we're talking about, IT infrastructure, the hardware. Okay, but IT infrastructure is not only about hardware. There's also a lot of components of software, right? With hardware, you also need to install some platform, some operating system, and some applications on top of the operating system, thus to provide services, right? So those software are also included in the IT infrastructure. Because why we're talking about this, because nowadays we put the more emphasis in terms of the computing power, so we invest more. And also on the other aspect is that nowadays those GPU cards, especially for the AI, they become more and more expensive, right? And also when you are trying to build a data center, you need to acquire more and more compute power, much more than before. Okay. And second one, data center from the cost center to value center. So this is directly according to what we're talking about in the title, right? From supporting node to center stage. Previously, you build a data center, that is your TCO, that is a cost, something you have to maintain, something is necessary to support your daily operation, that's it. But now you build a data center, it's a value center. The data center now is to create value for you, okay? To create actual benefits, to boost the profits for enterprise. So now the data center rule has been altered, okay? This is also very important. Third one is digital innovation platform, okay? From the DC become the cornerstone of enterprise digital and intelligent transformation. Why is that? Because now with this adoption of AI, every organization, they have to think about how you would build your digitalization future forward, right? You cannot wait and sit and just, stand by. You have to join in the trend and always thinking about how I can utilize AI to better facilitate my daily operation, for example, in my organization. Okay, if it's not only the chat box, how I can utilize AI with some knowledge base, perhaps can help me and answer me questions better, for example, within the Ministry of Finance, right? You give them some dedicated your knowledge base and for them to answer questions better for you, to help you, rather than answering general questions like ChatGPT. Okay, that's the idea. And then we have mentioned about the changes, right, of the new data centers. And now we will go to the resilience. Like I mentioned, data centers are becoming bigger and bigger and become more and more important. And also at the same time becomes more and more complex. Okay. And the resilience is the key because we invest a lot to buy a big data center. Very nice. We bought a lot of GPUs from NVIDIA, for example. Also maybe some other NPUs from Huawei, let's say, you invest a lot. Then you want your data center to be available to services almost all time, right? You do not want to invest big number on the data center, which can only provide services 50% of the time, right? That's the one thing. A second, you want your data center to be reliable. That means in case of disasters, okay, first we talk about reliability, disasters. Like I mentioned, it can be natural disaster, could be an earthquake, could be a flood, could be fire, or it could be human error. Okay, because we cannot avoid human error always. If you are using human beings to do the maintenance, there will be human error. And third one, as mentioned again, security, right? Outside security threats. There's always bad people. There's hackers. Those malicious attacking your data center. We do not want those things to compromise the services of your investment, right? This is why we need resilience. We need to build your data center with resilience. Okay, there's multiple factors. Okay, this slide I will just mention one idea, what we call open complex giant system. This is OCGS. This is not something invented by Huawei. This is a widely used, I would say, academical term in terms of defining and very, very complex big system, which is dynamically interact with outside and also changing dynamically all the time. So this is a very, very complex system. Okay, so I'm not trying to make it very, very simplified, which is this thing is not simple. Okay, we have to have the mindset when we talk about resilience. This is a very, very complex thing. Okay, because this thing is dynamic. All the system we're talking about various aspects. Okay, so this is the thing that we need to be prepared. Okay, OCGS, Open Complex Giant System, and later on I will just guide you through the every frameworks and steps how far we can help you make these things as easier as possible and give you the framework how to enforce the resilience. Okay, the resilience comes from design and evolution. Okay, before we jump into actual framework, there's another methodology, design and evolution. Okay, it's not only about design. Maybe you are thinking, okay, I do a resilience, I just do a perfect design. Maybe with the help of Huawei or some other genius from the academic. Design something that is very, very robust and very, very secure. That can be resilient. That is only the first step. Okay, that is very important, but that is not all. Okay, design is not all. You also have to consider the evolution, okay, of this resilience, because as I mentioned, I need to emphasize again, this is a dynamic system. Okay, you cannot rely on some hard-coded designing and implementation on the day one, and you are good to go. You can comfortably say, okay, for the next 10 or 15 years, I'm safe. Not like that. It's a dynamic system. So design is only the first thing, the first step. This is the upper limit. Okay, set the upper limit. Designing from your design standard sets the upper limit. But the evolution, the dynamic procedure will set the lower limit. Okay, so this is always a procedure of feedback. Okay, design with the AI native architecture, try to make the design as good as possible. And evolution, take advantage of agentic AI, for example, and various other tools to refine the design. Okay, to adjust the mechanism, to adjust your schematic, the schematic defense against all kinds of threats. Okay, design and evolution. Okay, resilience is a long-term job, not like finish at day one. All right. Okay, now we go to the chapter 2. Here we will talk something more into the detail. Okay, in 3 different sections. First, we talk about understanding DC resilience. We will talk about more to understand it better. And after understanding that, we will go to the key features of a resilient DC. I will right away give you the conclusions, what you need to consider when you are actually designing a resilient data center. And third will be the DC resilience maturity model and development framework. So this is also what we will provide to the public for your reference, okay, as a framework. If you would like this design, what are the framework and KPIs you will need to be considering? Okay, next one, please. Okay, so and understanding, we again go back to this one. Okay, can anyone tell me what are the challenges? It's already shown here, but I also talk about. Can you name any of the challenges that will tempering or hindering the reliability or the security or the resilience of data center? What you can imagine? Okay, the challenges. Any idea? First one, always we talk about natural disasters, right? Natural disasters. Okay. Second one, security threats. We already talked about security threats from the outside. And third one, the massive demands and burst traffic. This one I haven't mentioned yet, but this is also another consideration. Massive bursts in terms of traffic. This is about availability. Okay, I give you an idea. You design a system. The system is able to cope maybe 99% of the time in terms of the daily operation, right? 99%. But maybe for your organization, there's a couple of days among the year, you have a huge transaction happening within your system. Maybe it's about like annual paycheck, okay? And maybe some internal event, you would have very, very high traffic during that time. So we want our system, okay? 99% of the time they're stable, but with this 1% of the time, there's a lot of traffic. It will actually fail the system. We do not want that to happen. So this is another aspect to consider. Okay, the sudden burst of traffic, the access to your system, the read and write, multiple read and write to your system. And the fourth one, like I mentioned, unpredicted software and hardware defects. Okay, these defects could come from within the human errors of your administrators, your engineers of the system. Could also come from the the defects or the bugs that are within our operating system or software. So if you heard about last year, happened a couple of times from the cross-track, okay, that's a new release of update that pushed. Cross-track is a software, a security software. It's being widely used for organizations. And if you use that security software and it's a dependency on the Windows operating system, if you ever recall on the news, we heard about on the news that worldwide multiple Windows operating systems, they went down, right? You cannot really do that if that's Windows because of this upgrade from CrowdStrike. It has nothing to do with Microsoft, but the CrowdStrike, they put a new security patch and they actually destroyed the operation of Windows operating system. Okay, so that is the four challenges. I will repeat again. First one, natural disaster, right? Second one, security threats from outside. Security threats from outside. And third one, the massive demand and traffic burst. Okay, the third one. And the fourth one, unpredictable software and hardware defects. Okay, the four major challenges of building that one. Okay, I'll go to the next one. Okay, for the resilience, we wanted to be, we already mentioned the challenges. Okay, now let's define the resilience. The resilience is about fault tolerance and automatic recovery. Also two aspects. For fault tolerance means you have to have a hardline defense, okay? Whether it's about reliability or it's about availability. It's about fault tolerance. This is something more to the passive side. So you build a defense, for example, and it's a passively defend myself. So this is about fault tolerance. And about automatic recovery, this is to the active side. So we cannot rely on, the passive defense can secure us 100% of the time. There also has to be active measures. So automatic recovery, meaning we are fine if there's some certain scenario where the errors will be occurred, okay, and that was not stopped by our sense of the fault tolerance, which is okay, it's acceptable. But we have to have mechanism of automatic recovery, meaning we have softwares or scripts that has been written that will generate automatic response to certain errors, threats, and faults, and will automatically recover the system, meaning to heal it, what we call the healing of the system. Okay, these are two aspects: passive defense and active recovery. Okay. Okay. Now I believe we have a brief understanding of resilience. Okay, we talk about four challenges. If you recall, there's four different challenges, and we talk about there's two aspects you need to consider when you build a resilient data center. Okay, passive one and active one. And now let's go to the actual key features. Okay, where we will talk about four features of building the resilient data center. All right, and first. Let's look at this model. Okay, what we call this one, this is a triangle model, resilience triangle. Okay, this one will use the illustration to help you to understand better. Okay, this triangle basically suggests, okay, your system is running smoothly, okay, at this line, and there's a crisis happening at this point. Could be some kind of security threat, disaster, and now it will damage your system. So your responsibility of your system goes down to a certain level, right? And we mentioned we have passive defense and active defense. There's a healing mechanism, and there's also the bottom line of our designing of the resilience. So normally you will find your system will be recovered. Either this recovery is done by the machine completely automatically, or it's done by human intervene. For example, your engineers and administrators got involved manually, roll back the system, annually bring some copy back to the data storage, try to recover your original applications. Okay, but anyway, it will happen. After a crisis, after damage has been made, some recovery job will get involved. Okay, generally, the system will recover back to the original state. Okay, this is very, very easy to understand. And within this area, you see that the triangle, basically between the time of the crisis and the time of the full recovery. And here at the peak of the triangle is how much the damage has been made, okay, to the response, the compromisation of your response of the system. So this resilient triangle is here. As you can see, there's two lines. One is the red one, the other one is the blue one. And which one do you think is a better system among these two? Which one? Yes, the red one, right? The red one is the better one because it got recovered faster or more rapid. And especially look at the slope of this red line. Recover much faster than the blue one. And how we can measure the resilience is using to measure the area of this resilient triangle. As you can see, we want this area to be as small as possible. As small as possible means better resilience. Okay, so this one is, you see, much smaller than this big triangle, right? So this is the idea, how we can measure. This is what we use. Actually, this is being defined by the industry called destruction model. We use this one to measure the resilience of your system. Can you go back? Okay, the four features we will later talk one by one. Okay, in order to make your area of triangle as small as possible, what are you gonna do? Four features. This is not about measures, but the features that the resilient DC should have in order to have smaller triangle. First, uninterrupted services. Uninterrupted services in any kind of disaster or errors. Okay, zero disaster risk. Second, deterministic security. We want the security to be deterministic, not random. Okay, not rely on some firewall, some signatures and put it there. We don't even know how much can we defend against the outside threat. We want definitive. Okay, we want this one to be very, very short. Let's say, even it's 95%, I want to be sure to measure my system. Okay, not saying like I don't have any idea. We want our security engineer or network engineer in our data center to confidently see the word that I'm comfortable to say 99% of the threats I can defend. Okay. And third one, the elastic adaptation. Remember, we talked about 4 challenges, right? That's one challenge is called burst of traffic. This is one example of how we can cope that kind of challenge to make our system available, even during some peak moments, very, very high traffic throughput. Elastic adaptation. We need to have a system that have elasticity, not a rigid system. That system can flexibly expand, right? And can flexibly share the resources with each other. Fourth one, the agentic AI O&M. When we talk about resiliency, O&M is also very, very important because we want to introduce the AI into the O&M in order to, first of all, help you to better understand your infrastructure, and secondly, that AI facilitates the O&M also facilitates that I mentioned, active actions, active recovery actions in terms of self-healing, right? And in terms of fault recovery. Okay. And now we will go one by one. The fault tolerance, first one. Can you go back? Yes. The uninterrupted services. So we will go to these two. These two illustrations help you better understand. Uninterrupted service. Zero data losses, zero service interruption. 2 aspects. Okay. When we talk about uninterrupted service, always 2 aspects. Zero data loss. This we suggest to RPO equals 0. Any of you heard about RPO, recovery point object? Okay. 0 data loss means you have a 0 RPO, meaning during the 4 challenges we mentioned about the resilience, no matter what kind of challenge, you will not lose any of your data. No matter what, if you can provide service to your users, no big deal. We don't care about that. Even the service can down for a day, a week. We don't matter that. We matter if you lose any data. We do not want any data to be lost. Okay, this matters this aspect. Second is about zero service interruption. This is when we talk about RTO, zero service interruption. This means I do not care about losing the data. Okay, I care about to serve my users. I want my users to have access to my system 24/7, even during a disaster. But I don't care if they lose any data. Okay, for example, you are using WhatsApp. Let's using that example. I want to access to WhatsApp to message my loved ones, to telephone my parents. But during the disaster, they lost some of my chat history, which for me maybe is fine. Chat history lost, but I can still use the app. So this is about aspects of zero service interruption. And what would you think? Which one is more important to you to run a data center? What would you think? RPO or RTO? Yeah, could be someone would say RPO, someone would say RTO, right? This is all correct. Okay, there's no standard answer to this one. This one, we will have the right conclusion of this one only we look at the actual application, what kind of services you are running, whether it's a data prioritized, okay, if it's your database or a very, very secure file system of your Ministry of Finance, keep the very, very confidential finance documentations, okay, that you will prioritize this one rather than providing services to users, right? But for those transactional applications, like I gave you example for WhatsApp, like Messenger, then they might be prioritized RTO. So generally speaking, this is, we look at from application perspective, we have different measures for that. But remember, in the data center, you are hosting various of applications. It's a versatile environment. It's never one or two single applications. So generally speaking, those two are equally important. We want to realize the RPO to be as much as close to the 0 as possible, right? And RTO also, we want them to as close as to the 0 as possible. Okay, next one, please. And then we go to the feature number 2, deterministic security. What are we talking about? Okay, security. Again, we bring your attention to security. Three key points help you to understand. So by security, we mean your system will be unbreakable, step-proof, and compliant. Okay, what do we mean by unbreakable? There's attacks, security attacks, and if you have ever heard about all these, security incidents happens on the internet, there's various of attacks. Okay, we're talking about attack your applications, web-based, either it's a web-based, okay, or it's a mobile-based, okay, or it's the application that is completely injected into a certain hardware. Application attacks and network attacks, brute force attack, DDoS attacks, various of them, you name it. So this is about the threats outside. We want our data center to be unbreakable from these outside hackers when they are attacking them. Theft-proof. This is another measure. So apart from attacking, traditionally, hacker attacking your data center, try to do damage, try to destroy your system, right? They're doing damage. But there's also some hackers, they're the thief, okay? Thief kind of hacker. They try to hack into your data center to steal some confidential information from your data center. So we have to also be theft-proof, okay? So second aspect. Third one, compliant. We have to be compliant to the regulations. Whenever we're talking about running a data center for a large organization, there will be compliance enforced on you. So you have to also thinking about how can I build a data center to be compliant to the laws and the regulations. Okay, by laws, I'm talking about generally speaking, worldwide, the cybersecurity law, data security law, personal information protection law, okay, basic security requirement for general AI services, so on and so forth. Okay, next one, please. And third feature, okay, elastic adaptation. Remember that? Traffic burst. We do not want the burst to temper my operation, even though there's a peak, access to my system. I want my system to be flexibly extended. Okay, this is what elastic adaptation. So how can we realize that? There's a couple of key technical points I'd like to mention. So for elasticity, it's all about flexibility and scheduling. Okay, anyone of you heard about the load balancing? Elastic load balancing, right? And also resource pool or virtualization technology, shared resource. This is the key point that we can realize that. Namely, during, I give example, still we back to the peak access, maybe during the peak time of the year, you have a burst of traffic. So how would you cope with that? A burst of traffic coming in. We need the load balancer, okay, to divert the traffic, to evenly distribute the traffic across your resources in your data center. Not, only to one or two servers, which you were designed to host those services. Okay, we want them to intelligently to distribute that to other available resources. Okay, this is the first step. And how can you have facilitate that the traffic can be diverted to other available resources? Because all your resources in your data center already pooled, means it's resource pool. There's no siloed system. We're not saying one or two servers are designed dedicated for one application. It's all your servers are one resource pool. The resource can be shared. Okay, mainly when I'm in an emergency, I can lend some resources from other people. Okay, and who would decide whether you are in an emergency? Okay, the load balancer will tell me. Okay, they will tell me, okay, you're in an emergency. There's a lot of access coming to your room. Maybe you need to lend some space from others. This is the idea about elasticity. Okay, next one, please. And number 4, the agentic AI. We mentioned about operation and maintenance. Okay, this is all about the active recovery. We mentioned, right? Passive defense is one thing. We also need active recovery. When there's a fault, we want our system to intelligently, to be a very smart person. Okay, to also you can defend yourself, to heal yourself. Okay, and that's a concept I like to mention. Let's out DC. This is a very fancy concept for let's out DC. What does this mean? Anyone knows? Let's out means turn off the lights of the data center. Okay. How can you turn off the lights of the data center? Why? Because you do not need any human being to get into your data center. Okay. For AI to do the maintenance, AI does not need to light up the data center. The AI cannot see, or it can see, but it does not require the lights. Okay, so lights out data center means it's a non-mandated data center. We do not need any human manual observation, operation, or maintenance for a data center. Completely rely on the artificial intelligence. Okay, and to realize that, after realizing that, okay, I will just give you a conclusion. There's a couple of benefits that we could get from this one. Is first one, automatic risk resolution, like I mentioned. It can resolve its own risk of the data center risk and do the healing, right? Automatic change verification. This is another aspect because your data center, as I mentioned, is a dynamic system. We all experience your app needs some, regular release of update, right? The system needs to be updated, whether it's a functionality update or it's a security update sometimes. For the change verification, automatic, it will also manage that because the changing is also a risky job. When you're doing the changing to the system, you might be involving some unknown threats, or when the human is doing that, your engineers not install the package correctly or let's say fully or completely. It will also cause the shutdown of the system. So AI will also monitor that during the change procedure. And third one will be the automatic fault rectification. This is to how they can locate the fault. Maybe sometimes AI cannot 100% solve the problem, but AI will always help to rectify the problem. It will help you locate whether this fault comes from one port from a switch, that's a hardware failure, or this is a fault comes from one of the US system that it got, discontinued. Okay, this is where AI can help us do the fault rectification, which is AI is very good at. If we're talking about human to troubleshoot a system, 30 minutes to troubleshoot only one problem. For AI, 3 minutes is well enough, even faster. But nowadays, we all experience of a large language models, right? We talk with those AI chatbots. We know their capability on this kind of stuff. They will hugely, replace the work where previously human was doing a repetitive work, right? Like some labor work, repetitive work, documentation. But AI is very good at this. Okay, next one, please. And now we finished talking about 4 features. Okay, I hope you can still remember all those features. And now we're going to the maturity model and development framework. This is also, something we will give you a methodology. Okay, after talking about features, and now we're talking about how. Okay, the frameworks, maybe some frameworks you can follow. Maybe it's also a KPI you can set up in your organization to measure your own resilience. Okay. So the DRMM, okay, data center resilience and maturity model. So it looks like quite complicated, right? There's some 5 levels of measuring your data center. Okay, these are some standards and protocols and features used to measure which level are you. Okay, 5 levels of the data center. I will not go to them each one by one because that will take a lot of time. I will focus on the key process. Okay, what are the metrics we use to measure? Okay, first one, availability. Again, we mentioned this again. Availability means we want our data to be available even during fault. Okay. Resource elasticity. We talk about elasticity, elastic adaptation, resource pooling, right? Second. Third one, security. Again, we talk about security. O&M. So you will notice that these key process areas or metrics that we use are exactly the challenges that we mentioned, right? Still 4. You remember there's 4 challenges and 4 features, and now we're using this one as a metric to evaluate your data center resilience. Okay, I will repeat again: availability, elasticity, security, and O&M. Okay, and thus, based on this one, you will have 5 levels of different resilience. Okay, next one. Okay, the resilient DC development framework. So after the maturity model, and now we will actually go to the framework. Framework gives you the blueprint or roadmap on how you can fulfill. For example, after you use the metrics and you evaluate your data center, it's currently at level 3. Level 3 sounds not bad, but not the best. Maybe you want to evolve next year to level 4. What are you going to do? Right? This is what the framework is going to help you. All right. So within the framework, there's 4 layers. Okay, we will not break down each layer, but the framework we follow the 4 layers, which are the 4 aspects for you to consider. First one, the enterprise DC infra, the architecture layer. The architecture layer. We are talking about actual infrastructure and designing and planning of the architecture, okay, of your data center. Second, it's about the operation practice layer, where you actually have the resilience DC indicator system. Okay, this is one of the key points. And you also have intelligent DC operations at this layer, okay, to do the assessment, to do the management. And third layer, we're talking about the common reference framework layer. So in your organization, you might be also using this one, okay, as we already talked about DCMM, one of the frameworks. And there's also other frameworks. You need to have a framework to dynamically adjust and evaluate. You remember we talked about DC. Resilience is about design and evolution. how you can facilitate evolution, you need a certain framework to guide you for the long-term resilience evaluation and evolution in your organization, right? And the fourth one sits here vertically, the intelligent resilience evolution mechanism. Okay, so let's go back to this one. Okay, I will try to re-elaborate, just make sure everyone's understand we're on the same page. All right, here the framework we're talking about. Put this framework into your data resilience in your data center, thus to help you from the design and evolution for the long-term reinforcement and evolving, right? Upgrade your data center levels. Again, you are level 3 right now. Why you are level 3? I give you example. Why you are level 3 may happen because within the framework, you just check the framework as a map. You find, okay, my data center, I do not have resilient DC indicator system. And I do not have intelligent DC operation when I manage the system. All my operation and management was done by my engineers, by my administrators, by human beings. Then you will find you do not have this layer at all, which maybe make your data center a level 3. Just an example. So this one is for you as a map. You treat this thing as a map. Check your data center. Whether I have all the enterprise DC architecture layers within this one, are all the components in my data center? Okay, we do not have to quantify them. Okay, but from the concept level, do we have such components? Make assessment first. And move to the layer 2. Do I have any of them? Move to the layer 3. For the future forwarding framework, do I have my own framework, my KPI? I already set it up. Either of them in my data center are your organization strictly follow those frameworks, try to reinforce and improve the resilience all the time? Framework, check your framework. And the fourth one, the intelligent resilience evolution mechanism. So these are some mechanisms that we put here as a vertically. This is help you to dynamically adjust, okay, the distribution of the components within these 3 layers, and also put different weights on different layers and components to further do the estimation. Okay. Next one. Yeah, this is the framework of audit example 4. Detailed discussion. We can go to the next one. Okay, chapter 2 not finished. We're now going to the chapter 3. Okay. Anyone has any questions or comments? Because I just try not to be too intense. Okay, we do not try to ingest too much. I want them, each of you at least, bring back home 1 or 2 new ideas. Okay. If no question, I ask question. We have gifts, right? For the question. We have. Yes, please.
Do you have any data centers like you mentioned in Sri Lanka?
I believe my local colleagues answer better, but we do have the data center in Sri Lanka, I think a lot. If you are in Sri Lanka, I think not.
Yes. We have one in Dialog Data Center is actually one of them, and the oral data center is also done by us actually. Yeah.
Yeah, we've been implemented many data centers. Actually, in Sri Lanka, I think not that much. But if you talk about Asia Pacific in general, we've done a lot. But if you're asking about a resilient data center, so today I'm talking about ultimate, the perfect data center with resiliency. Okay, these kind of data center we are not yet to see. There's multiple of them in China currently. For the major banking sectors, for the FSI, where they have the highest standards for resiliency, they are building according to this. This is also why we released this white paper jointly with ICBC, Industry and Commercial Bank of China, which is the biggest bank of China. Also, I think one of the top 5 banks in the world. Okay, and so let's see. I mean, in Sri Lanka, later on we will also talk about this the feasibility, right? Here we are mentioning about the ideal scenario, but when we go to the actual implementation, are we have to fulfill everything? Not really. Okay, we also have to be realistic sometimes to fulfill the actual needs according to your performance and the resilience. Okay, this is almost like your preference. If you prefer more to performance or you prefer more to resilience. Okay, and I will. Any other questions? And if there's no question, I ask one question. All right, this is right. It is according to what I've been taught to you in the previous slide. Okay. Anyone can explain what is RPO and what is RPO? RPO? Yeah, that is RPO. Recovery point of object and recovery time of object. Okay, but what is the underlying meaning of that? RPO more focused on what? Yes, data. Very good answer. RPO more focused on data. We do not want to lose any data. RTO focus on service availability. Right? We want to have this. Very good. I think we can give them gifts. Right? Thank you. And now we will go to the chapter 3. Okay. Resilient DC planning and construction. Okay. Here we will go to some more details talking about the resilience DC planning. And this part we will actually have quite a lot of slides. Okay. And we will try to. Do we need any break? You think? Continue. Okay. Then let's continue. Uninterrupted service. Still the 4 aspects you remember from the last chapter, and now we will break into each of them. And in this chapter, we will actually talk about architecture design. Some active-passive data center, if you heard about, active-active data center. Okay, multi-active data center, of those kind of things. Okay, let's continue. Next one. Okay, again with some intros. Frequent faults lead to service interruptions, data losses, and strict regulation requirements. Okay, these are again challenges, the faults. Basically, the loss of all the disasters we mentioned, right, and also the strict regulation give us the necessity of building a uninterrupted services of our data. Next one, please. Okay. From DR to active-active. This is what I mentioned. In order to facilitate your resilience of data center, when we talk about uninterrupted service, the obvious answer and the easiest way, or also the widely adopted way of doing that, is build some more redundancy, build some more available resources, which is why we're talking about from DR to active-active. Firstly, you build one primary DC and one disaster recovery DC. Right? One is active, the other one standby as a backup. Okay, that's not really Techo to run services. Now we would like to see active-active, which is the trend of the current stage and also for the later 3 to 5 years. People are building active data center for highest availability and reliability. Okay, and we are building active data centers. Okay, focus on a few categories. All right, consistency, availability, compliance, performance, and cost sensitivity. Okay, building a active data center is beneficial not only actually to the reliability or uninterrupted service, also will facilitate your service and resource scheduling and sharing. Okay, and let's look at this. So traditional active standby DR focus on intro or remote state zero data loss. So if it's a DR active passive, normally it can only give you the guarantee on RPO, right? Because you basically back up or your data from one data center to a remote data center. Okay, your data will be kept there. But in case of disaster, if your primary DC was shut down, you cannot really access any services from the remote DC because remote DC is only kept your data. is only used to capture your data. This we realize RPU 0, but we cannot realize the 0 RTU. Okay, this is a traditional active passive. And for active-active DR, it focuses on ensuring zero service interruption, namely RTO. Okay, imagine the scenario. Active-passive. I realize RPO 0, but what makes me feel, still not satisfied was if my active data center went down, I cannot really access my service from the standby data center. But only that, I also build the same service architecture, the service layer, the applications, the resources on my DR, which we can realize. And after doing that, it's not yet finished the job. We have to synchronize to data centers, right? We do not want disaster happen, even though I access service, access data, but somehow I cannot log into my account because the data between two data centers are not synchronized. For users, they were using one data center, and when you shift them to another data center, they cannot even log in because the data was asynchronized. They cannot even get their credentials correct. That will be problematic. So active means same amount of resources in terms of supporting your applications, as well as the storage for the data to be replicated at the real time. Also, okay, to ensure the consistency of the services, applications, data between two data centers. Okay. And then we again get back to the category. You will understand what I'm talking about. First one, consistency. Building active-active consistency is the most thing to be considered. You want reliable synchronization of your core data between two data centers. And this synchronization facilitates the application to treat underlying resources as one. But for application, I do not have to care whether I'm running my application on data center 1 or data center 2. Doesn't matter. Because those two data centers are fully synchronized, I can treat them as single data center. Single data center with double the resources to support. Okay, consistency. Availability. Again, availability. Same idea. Okay, about high availability. Because one data center down, another data center can also carry the service, increase my availability. Right, solve the RTO. So this is the second thing we want active data center to realize. 99.99% normally. If we have any kind of active data center, doesn't have to be from Huawei. Okay, any active data center that you would performing and running will give you 99.99%. This is some guarantee from all kind of technology. 99.99 availability. Anyone has idea what does this mean? For nice, 99.99%. It means during the time of a year, the annual availability. So 99.99% of the time within the year, my system is accessible. I can access my system, running my service. And how much time will that be? 99.99. Basically means 99. If you do the calculation, means only 15 minutes I cannot access during the entire year. 50 minutes. Potentially 50 minutes I cannot access the system. 99.9. Only 50 minutes. Okay. This is the bottom line of an active data center. And later on we will also talk about how nowadays with different layers within the data center. We talk about layers, right? Remember, with the layers refinement, we can even make 99.99 to 99.999. 5 nines. Okay, 5 nines will indicate that only 5 minutes within a year that your system is down, which means you cannot access the service. Okay, and third one, compliance. Very important, very important. Okay, this has already becoming a trend in many countries where they have a large infrastructure building for data centers. The government, okay, from the nationwide, they are putting the strict regulations on data center compliance because data center is a critical infrastructure for the nation. For the most of the world, they realize such because you capture a lot of personal data, okay, and you serve the critical infrastructure services for your citizens, for your enterprises, for the society. Okay, so this is very important, compliance. And later, performance and cost sensitivity, I will not talk in detail, but still we need to consider. But remember, consistency, number one, availability, number two, compliance, number three. Okay, next one, please. So this is here, we're just giving you some examples of
location, but not the other. That is why we want to separate them from geographical location. Example. Okay. So for example, you have one city, you have one data center. Another city, you have another data center. And these data centers, they could be hundreds of kilometers apart, no problem. Or even up to 1,000 kilometers. That's not a big deal because this is active passive, right? We're not supporting services from both data centers. There is a primary data center. The other one only to replicate data. For replicating data, we do not require consistency and synchronization, right? We can just replicate whenever we got time, whenever the bandwidth is available. Just replicate as you want. So active standby. And then we will go to active. Potentially a two side three center. I will illustrate. Okay. First one from active. So again, one data center at city A, the other data center this time should be in the same city if you want active, not in the city B if you want active. Why is that? Anyone has an idea? Why for active I can only build within a city?
Maintain the high availability in systems.
Yes. 100% correct. Consistency. Because consistency rely on what? Rely on the synchronization of data. If you want, give you an example, if you want the data to be synchronized, what do you need to consider? Latency, right? Latency and bandwidth. You want the communication line, the transmission between two data centers to be as fast as possible, as real time as possible. If you have a very long distance, what you will have? Latency. This kind of latency is not, for human beings, for us, we cannot really, accept. But for data, this is very critical. Okay, I'm sure you have experienced latency when you are having an online meeting, right? The online meeting could have, couple of 1 second or even sometimes up to 2 seconds of latency. If you're playing a game, normally they will also tell you what is the latency, right? Couple of hundreds of milliseconds, normally you will also feel fine. But for data center, we cannot tolerate that. We need for active data center to have the latency around 5 milliseconds, sometimes even smaller, 5 milliseconds. In order to reach such a high level of latency, we have to build the data center as close as possible. Okay, so that's within one city, but still under two different premises, not within one premise, because we still want to defend the natural disaster, right, on one premise. So let's see, normally within 100 kilometers. This is the baseline. Cannot go beyond 100 kilometers. Why is that? Because the current optical technology, which is based on fibers, the optical technology currently human being has, we cannot support a latency less than 5 milliseconds if the distance go over 100 kilometers. Because the speed of light, there's a limitation. We cannot go beyond that. So 100 kilometers, this is it's universal. Remember this figure, 100 kilometers. Within that, 5 milliseconds of the latency. Okay, then this is about active, you realize. And how about CDB? So in this scenario, I'm talking about story, okay? You are evolving from active standby to active. So you build one extra data center in the same city, and how are you gonna do with the CDB? You can still use that. Even though you have active, you do not have to, get rid of the old data center completely. You can still use that as a disaster recovery center. This is what we call two-side three center, which actually also increase the reliability overall of your resiliency, which, as you can see here, now the disaster requisition happen between each of the data center in the city A to the city B. They will all have the asynchronous replication of data. Okay, so this one serves as a disaster recovery center for both data centers in the CDA. So this we call active plus one standby, and all of them linked together. This is two-side three center. This is mode B. Okay, and mode C, which I mentioned about multi-CD, multi-active. Just imagine this one as the ultimate roadmap for the active standby.
active standby first developed to two sites with center, and later on you introduce a third CD, the fourth CD, and you can have a celled architecture to link all the data center together. Okay, within the CD, still active, across the CD, active standby. Okay, this is ideal. I think very easy to get it, right? Next one. Okay, so after talking about that, let's first go through them one by one. Okay, I think today I will not talk about multi-CT, multi-DC because that is first of all, I think it's not active standby and active today first. Okay, so first, active standby. There's some design principles within the active standby. We already talked about active standby from the design, data center level is very easy. But within the data center, also some frameworks and standards. 3-2-1 standard. Okay. 3-2-1 standard. 3 stands for 3 data copies. If you're building active standby, okay, 3 data copies, 2 types of backup storage, and 1 remote center. Okay, the one very easy to understand. 1 remote center because I'm active standby. On day 1, I have a remote center, which is already passed, and 2 types of backup storage. What does this mean? I already have backup. Why I need 2 types of the backup storage? Because the system normally requires this actual layer of the defense, whether it's against security or it's against reliability, and also according to the regulation. By this, I mean, normally you will have 1 type of backup storage, which is a dedicated backup machine, or it's a general storage. Okay. And the second type of backup storage, we're talking about tape libraries. Okay, right? If you heard about tape, it's kind of like their own technology people were using to store this code data. But till the day, tape library somehow is still safe in terms of defending threats because tape library could be treated as an offline backup, right? Because it's tape, it's a physical one, not that digitalized. Even though it's not digitalized, maybe not that convenient to use, but in terms of defending against hackers from internet attacks, it's kind of effective because it's offline. And second of all is compliance. You know, we also have this compliance from the government. They will require you to put long-term retention of the data. They might be asked you to keep the record of the Ministry of Finance for 20 or 30 years. Okay, if that's the case, if you're using the backup storage, is not really cost effective because that's a huge amount of data. That's why people will choose, okay, I put it on tape, which is very, very cheap material of storage. Okay, so 2 types of backup storage. 3 data copies. What does this mean? 3 data copies. I will guide you one by one. First data copy from the DR storage. We're talking about active DR, 2 data centers. One is here, one is here. First data copy, DR storage, which means you always have storage. Remember, 3 key aspects of the computer system. Storage, one of them. Production storage will replicate data copies to the disaster recovery storage in the disaster recovery center. This is the first copy. Second copy, backup storage. So apart from production, which runs your production activity, you also have backup storage to back up the data from your applications, virtual machines, or even a production storage. So the backup storage is always there in the production center. We will require you to copy that also to the backup center. Sorry, the DR center. Okay, also copy to the DR center. Okay, so how many copies do we have right now? 3. We already got 3. One is here, DR. One is a backup storage at the primary site. This is already another copy. Okay. Third one is the replication between the backup storage to the DR. 3 copies. Okay. And this 3 copies seems a lot, but from the architectural perspective, seems very, very logical, right? The production storage to replicate, that is for sure you need to support all the business running or in DR as well, right? That has to replicate, and dedicated backup to ensure within the site you have a secondary copy. Okay, and also we would like to replicate this one to the DR side to further ensure even for the backup, I have a backup of the backup. Okay, next one please. Okay, this is the one of the case study from the bank, and it's very, very common in terms of following the 3-2-1. I think this is widely adopted if it's for disaster recovery, for active and standby setup, widely adopted this one. As you can see here, very easy to understand, right? We try to make it as easy as possible. Here's some applications, right? It's a core banking, it's Oracle database. Anyway, here's your applications from credit card, from your financial statement, e-banking for you, so on and so forth. And then you will have some switches connecting to the storage, right? Servers only here with some switches connecting to servers. This is your production side. And the first copy comes from where? Comes from across the site. Okay, the production storage. You will have maybe 2 sets of production storage and they copy to each other. Okay, first copy. And second, the backup storage. Okay, the backups, the application data, the virtual machine data, and your storage data. Second copy over here. And third copy, the remote replication to another backup storage or archive storage. Could be backup or could be archive. Remember, we talked about 2 mediums, right? So for the remote, you can replicate to a dedicated backup storage or replicate to a tape library, also fine. Okay, depends on your requirements in terms of TCO and in terms of performance. Okay, next one, please. And now we finish about the active passive, the active standby. Okay, and now we are going to talk about active. So before that, again, question. Oh, please.
Because in the server side active stage, if one server is attacked, whatever, because of both are active, second one also will be attacked.
Oh, that's a good question. Second one will not be attacked. This is why we have active mechanism here, because if let's assume active one got attacked by the hacker, which will immediately do what? Fill over all the traffic from that one to the other active center, which will not impact any RTO or even RPO because data was synchronized. But you're concerning that maybe my servers are all linked together, right? Attacking one active data center could potentially suggest that the hacker will have the capability of accessing my secondary data center. That is not the case. That is not the case. They're from the security level, from the border security level, they're still independent. Each of the data center will have their own network borders, namely the firewalls, sandbox, security devices, security softwares covering the EDR, XDR, so on and so forth. They're independent. We form the active mechanisms through what? Through the consistency of data and the low latency transmission between the information between the system to enable them to work as a unified resource pool to support your applications. So for hackers, if they actually get into the application itself, whether it's got into DC1 or DC2, it will not spread to another data center. As long as the hacker has not realized the actual mechanism to route themselves to the secondary data center. Okay, I give another example for you to better understand. For active, you're installing the applications, right? Applications. So you are saying, okay, if the application is still not yet stable,
I leverage my platform way. For example, if you are entering the data into our server index, service updated to the data. Same time, active server also will be updated.
no. This is what I'm going to elaborate. There's 2 kinds of applications two form factors. One we call stateful, the other one is stateless. Okay, in active, or let's say in active passive, most of active application we're still doing the stateful application. While in active, we tend to encourage stateless. So this will answer your question. You have the application installed on one PC. Let's assume that, okay, active now. You doing the regular update of the application. Does that suggest you update one in one DC, the other DC you can just neglect? Not the case. You still have to update the same stateful application on the secondary DC. Okay, in order to facilitate both of them carry on business to the outside users. Okay, this is the idea for the stateful. Okay, the applications. Okay, when we are talking about stateless, that is another trend. When we are having the stateless means, we will also maybe I have a chance to talk about that later, but I just give you a nutshell. Stateless means what? There's no state of applications stored on either of the data. The state of application stores on where? State servers. Those servers stores the metadata, the user data, configurations, and all the necessary components to start the system. We centralize manage them in one location. So it's realized all your servers across data centers. Doesn't matter. I don't have to store any data on each single server, meaning I don't care if my application runs server number 1 or server number 2 in DC number 1 or DC number, doesn't matter. Whenever we start a service, all the servers start the application fresh from scratch. It loaded all the state from I mentioned from the other server, which centralized manage all the configuration. It load everything from there and start everything from scratch. So this is where we call stateless. Okay, in this scenario, we'll also answer your question how to realize the highest availability and also prevent attackers to take advantage of the breakthrough any single server they want to contaminate. Not the case, because all my servers are if you shut down the service, all the servers are unified, are the same. You cannot get any data on the server. The server is just a runtime, just the CPU, nothing at all. And I store the configuration of my users in other locations. Okay, so this you will realize the highest flexibility of distributed workloads and also realizing active, which we will mention later, but doesn't harm like I talk about here. So having active, the thing that I just elaborated, the stateless, is actually the biggest challenge of having active. Why is that? Because stateless against the stateful will require a lot of resources, energy, and knowledge to do the re-architecture, to change your application from stateful to stateless in order to fit better for the active, the full stack active. So this is actually the biggest underlying challenge, not from the hardware perspective or geographical perspective. I just put some more resources, not like that. We have to, this is something very, very technical. Look into your application, do the stateless re-architecture, reform, and rehost, and then bring everything to active. Okay, so thank you for the question. Very, very good one. And then we can go this one actually also according to what I just elaborated. Active. Okay. It's kind of small, but I hope you can see the general idea behind it. So there's two kinds of active. Okay, as I mentioned, realizing the full stack activity is hard, right? Because of the stateless. I think there's somewhere also mentioned. Stateless application reconstruction and data sharing are required. This is hard to realize the full stack active. But we still have a role for you to fast adopt active, and then generally evolving to the full stack active, which is application level active. Okay, happen from the application level. We do not require the stateless because, as you can see from this graph, even I have DC1 and DC2 at two different geographical locations, but I only have application installed on both DCs, but not the storage. Namely the data layer, whether it's a data storage database, the big data platform, data warehouse. Those are still within one site. And that site is still using the one-way replication to the other site. So in this case, I can still do state 4 because the data is still within a single place. And my applications are accessing the same DC1 data layer. Also eliminates the requirement for higher consistency across DCs. So if this DC can also have larger latency, right? And the replication can happen sometimes even asynchronous. So the data will be still kept within a place. I just build another compute cluster to host application. This is application level active-active, meaning you still can reach RTO almost 0, right? But previously we mentioned why we want to have active-active because we want to have 0 RTO. At this case scenario, imagine that if this side, some errors happen within the application of DC1, my DC2 can take over all the services. No problem, because I implement the same configuration, same devices, same system, everything the same, mirrored on the DC2. Okay, so this is, I would say, a short-term plan before getting to the full stack. Okay, and while evolving this one to the full stack, what you're gonna do is you also need to realize the data layer synchronization and consistency. Meaning at this stage, so comparing to application layer, so application layer from this user experience, everything has been realized, active-active. But there's also a disaster when this happens, you will be compromised. What is that? If the DC1 entirely down from the data layer. If the data layer of this went down, because all these two applications from two DCs are accessing the same data layer, if this one went down, your service completely went down. Okay, the service will go down completely. So that's why we want to also facilitate the consistency and data synchronization between the data layer and each of these applications you go to access your own data layer, which facilitates the DC1 and DC2 can operate completely independent from each other, no matter which data center get from. Okay, but this data synchronization and data layer consistency, as I mentioned, will require the stateless reconstruction of your applications. Okay, so then let's go to the next one. I think I will have a bigger slides to describe the application layer. Okay, so I will talk application layer a bit more. We will not go into detail of active-active because I assume currently in the stage of Sri Lanka, maybe you are in the trend of transition from active standby to active-active. So application active-active was trying as a short-term solution to realize some kind of RTO equals 0. Okay. So this is application layer. Again, we break down this one. Okay. Normally, when you build active-active from application layer, there's some certain aspect you need to consider. First, network access layer. Second, application platform layer. Third one, database layer. Fourth one, data store layer. Okay, we will go one by one to see what I'm talking about. So, network access layer. Anyone has idea why the network access layer is very, very important? It's over here, network access layer. You will see the component called GSLB. I will talk about this. GSLB. Okay, and DNS. Okay, these are very, very important. Why is that? Because we want to distribute the traffic, to reroute the traffic, to let my application seamlessly be diverted between data centers. We have to have a mechanism for load balancing, right? For load balancing and domain name system. Okay, so do that. That is from the network layer perspective. Very, very essential. If you want to build active-active, GSLB and DNS are necessary to have. Okay, this is from the network access. An application platform. What are you going to do? Application platform. Where? Sorry?
Using the same layer.
Yes.
Can use the configurator to give the traffic between the user and the data center.
Exactly. That's correct. And we already talked about application, right? Application layers. 100% correct. Thank you. So application layers, all right. We need to do the replication, right? And application also has to do somehow, to identify I'm now running on the active architecture. This is from layer perspective. So application layer should do the configuration at least. I'm not required at this stage to completely go to stateless, but even it's a flexible, if say for maybe some stateless, but you have to do a configuration to the application layer have to facilitate the actual users running applications. They will be seamless. They don't have to worry about which data center to select. Okay, application layer and database layer. What are we going to do in the database layer? Any knowledge on Oracle, for example? What Oracle does in the database layer when they're building application layer active?
You can say it is in the physical layer.
Yeah.
We can store it. We can do the other storage thing in the application.
Yes.
So I think in these three, you have to protect more than the other two layers to the data.
Yes.
So I think you really you get by the most of the things how.
Layer active. Everyone accessing the data from DC1, so DC1 has to be active. At the same time, we facilitate DB synchronization to a potential DC2. This one serves as a standby to the database. And when this is a standby for the database, suggests what? Any idea? If a standby database suggests what?
If there is another vulnerability or the index, we can use that to detect it.
Exactly. But to which extent? Then it's a standby. To which extent? Can I treat this standby as the same functionality of the primary?
We can use the active passive. So, for example, the first one is I think we can use as an active one. So there is a vulnerability or the defects happen to the organization or the database. So we can bring data from back from the database.
Yeah, bring data back from bring data from the secondary data center, back to the primary. This is why we talk about application layer, the drawbacks of that. The database, similar for the storage. The secondary database, again, Oracle, DB2, Gauss DB. We have one primary, two secondary, and no matter which secondary we're talking about, this one can only support a query. Okay, in terms of database perspective, you can only query, but you cannot make any modification, deletion, so on and so forth. You cannot create charts, create table. You cannot do that. The only thing you can do is query, because this is a one-way synchronization. Okay, if we want to fall back, that is called reprotection. We got data back. So only the primary side database is the full functional database, has all the capability: creation, query, deletion. But this one only query. So that's why during the disaster, what will happen is we should use this one, like this gentleman has just elaborated. Copy the data back to the primary side, and then again start the service on top of the primary side. So this is about the database. And then the data storage. Okay, storage, the same idea, but here I would like to mention a key point is in the resilience design, the storage, when we put a lot of emphasis, storage is decoupled. If you ever heard about a hyper-converged infrastructure where they use distributed storage, meaning you do not have the dedicated internal storage, but to use the local disk on servers. That in the resilience designing is not reliable enough. We need to have dedicated storage, external storage devices to fulfill the requirement for resilience. So remember this one. This is very, very important. In resilience, storage need to be decoupled from storage. We need dedicated enterprise storage to store the data externally to give us these extra layers of resilience. Okay. So similar to the database, the storage, you will have dedicated storage. Either it's a block storage or file storage. Stores the data, doing the data synchronization between sites. During disaster, it can recover from the secondary side to the primary side. Same idea of that. Okay, so this about the different layers of the application-based active-active, which can realize a certain increase or reinforcement in terms of RTO, largely increase RTO. And for the RPO, also guaranteed because we have the secondary side. So on these circumstances, maybe it's not the highest, but we realize could be realized a near zero RPO and maybe hours level RTO, because there will also be potential breakdown of the business. But we already bring down the RTO to hours, meaning that during a year, you have a couple of hours. Remember, we mentioned 4 nights, right? 99.99, 15 minutes. If you can design the system very, very good, we can almost close to 99.99 on the application layer active-active. Okay, so this is about the application layer. And let's move to the next one. Okay, so after talking about that, now we go into some different aspects to treat this resiliency. Okay, we talk about design, active-active, application layer active-active. There's another thing we need to consider in your organization, drill. Okay, disaster recovery is not only about we design, we evolve, and we just sit aside and let it go by itself. Drill, practice. You have to practice. Practice your mindset and practice your system. Okay, after building, you cannot wait the disaster coming and to test and examine your design resilience. You need to run man-made drills. So drill, important. And how you can plan the drill and perform the effective drill is also very, very, technically challenging. Okay, by drill, I mentioned your drill scenarios. You need to design the dedicated scenario for the data center drill. Okay, how you can design? There will be a drill scenario library. Okay, normally will be provided by the design recovery solution providers, or let's say in general, the ICT provider from Huawei, when we're now talking about resiliency. Okay, the drill scenario library to cover the city level disaster, equipment room level disaster, or it's a cabinet level disaster, or it's a single infrastructure or environmental disaster. Okay, and with this scenario being classified, you need to run the drills maybe on every different scenarios to test your resilience, the actual response from your design. Okay, and the drill platform, this is also important. Drill platform will facilitate you to run the drill in the automatic way. Okay, we do not want to run the drill and involving maybe 20 or 30 engineers and running the drill for 3 days. I'm doing the drill. I do not want to temper my actual service and business. Right? I cannot tell anyone, okay, stop, go holiday, go back home, because we need to run drill for the data center. People will go crazy. That's not logic. So you need a drill platform to facilitate those drills, to automatically orchestrate the drills. This is the platform that also should be provided alongside the solution. No matter who is providing the resiliency solution, they are giving you active-active. Or let's say, even active-passive should also support drill. Okay, drill is important for your business, also important for complying with regulations. The regulations will also normally indicate that you need to run maybe 2 times of drill a year, so on and so forth, and there will be auditing, right, to check about the drill performance. Okay, this is the drill. Very important, okay? Mindset and above having the proper way of conducting the drill. Okay, next one. And here we just got a nutshell with multi-site, multi-active. We talk about active-passive, active-active, and ultimate, as I mentioned, is multi-site, active-active, and multi-active. Okay, so basically the objective of that is, people are chasing the ultimate goal of the RPU and RTO, right? That's why they figure out this kind of very complex design with multi-cities to realize zero service interruption means RTO zero, zero data loss, RPU zero, and minimal idle resources. This is an actual thing they would like to realize through this one. So not only design towards the reliability and availability, but we also want to realize no idle resources to increase the resource utilization by introducing multi-active. Why is that? Active means the resource can be used to carry services. The name behind active. Passive means it can only be used for backup, for disaster recovery. Cannot really carry on services. So we do not want having many data centers at different locations, but most of them are passive. Maybe during 3 years you have no any kind of disaster, the passive data center will only be used during drill. Right? So that's a waste of resources, and we invest a lot. We want every data center we pay to also can run services. That's why multi-site, multi-active. Each data center should be active to the other. And between the active data center, you forge what we call active passive, right? If the distance is very far. But in this content, each of the data center are active to the other, meaning they can carry out services independently. So this is the general idea of the multi-site, multi-active. Okay, we go next one. Okay, and we're closing to the summary of this part. Okay, so this is one the customer voice from ours. Okay, for one of the CTO of the leading bank, and basically discussing of the resilience, for example, for banks, and there's some requirements and applications and thoughts we made. Okay, so from his words, let's just emphasize a few. Okay, so DR requirements. Okay, from the practical perspective, you focus multi-active. If you were to adopt multi-active for core services, okay, remember we have 5 layers, right? Telling you how to classify. Same from our customer, from the actual CTOs of the organization. Same idea. Core services, okay, aiming to improve city-level disaster capabilities. Those very core services, you go with multi-active, right? And for the capacity requirements, what is that? For the capacity that has reached limits, I want to increase the utilization ratio of my resources, I go with multi-active. 2 aspects. If it's very core applications, very essential, I go with multi-active. If the capacity of a certain application reach a certain limit very easily, I go with multi-active to ease the resources, to make the resources shared across the resource pools. 2 aspects. One is core application, which is very essential. Second is capacity. For those application consumes a lot of capacity, requires a frequent capacity expansion. Okay, we go with multi-active. And I think the next one we can talk about, the classification from the bank. Let's have an example. The channel applications. Bank, in bank they have channel applications. They describe it like that. This is the first candidates for implementation for multi-active. Why is that? Because channel applications, they are much newer applications. From day one, they are stateless. You don't have to do any stateless reconstruction for those applications at all. From day one, it's stateless. Channel application, naturally stateless. So you don't have to make that much of the redevelopment. You can easily make them multi-active. Okay, that is from the nature of stateless. Second of all, core customer-facing services. Okay, this you implement the category, mainly the core application that he mentioned in the first place, production and user data, which takes share. Okay, these kind of things we will also be prioritized for multi-active. This is from data perspective. You also need to look into that, because if you're building an active or multi-active, data has to be shared across DCs, sometimes across cities, sometimes across countries. You need to determine whether this user data under the privacy law are okay to share across data centers. Okay, so if they're okay data, and then you can go with multi-active. And for the general or global data, which you cannot be shared, this is restrained by technically and regulation. For those data, you cannot really get out the data center to the other, then maybe you can only facilitate within the data center, but not multi-active. Okay. And last but not least, I still like to mention about O&M, because this is the point that people tend to neglect in the resiliency. Okay, we talk a lot about architecture, talk about RPO and RTO, design and evolution, drill, so on and so forth. O&M is also very important to facilitate you to monitoring the health status of your data center. Okay, to make fault rectification, we mentioned, to make the fault healing and self-recovery using AI to further help you to offload the human requirement in terms of managing that. Okay, O&M. And next one. Okay, and then is the future forwarding. Here, I will mainly focus on how you're utilizing AI to help you further strengthen your resiliency. Okay, so AI, as I mentioned, in the O&M, you can utilize AI a lot, right? This is to give you a nutshell. So apart from office agent, program agent, and industry agent, which we're already familiar where you're using AI, AI is heavily engaged in our data center O&M, right? And also in the context of AI, computing power becoming more and more also require us to build the data center more and more resilient. I also mentioned it at the very beginning. So this slide basically they're illustrating that your data center becoming more and more expensive because you have a lot of AI computing power. And secondly, the AI training and inference cannot suffer that much of an RTO, right? Because you want the service to be accessible at all times. That's why you need to build a high level of resilience. Next one. Okay, and just a small summary for this chapter. Okay. In conclusion, a multi-site, multi-active architecture not only protects your service, but also lays a solid foundation for service expansion. The key conclusion we drew, right? Not only for solid foundation, for reliability, for availability, but also for service expansion. When we talk about active, okay, and multi-active. So this is a very important conclusion. Okay. Help you strike the balance between stability and flexibility. One side stability for the reliability, expansion for the flexibility. So basically stating that active is very good. No drawbacks at all. Everything about active is very good. And moving to multi-active is even better, which is the fact. Okay, this is what I would like to summarize this chapter. Okay, next one. Next one, please. Okay, so on this one, I will be quick about this one because here we're talking about undeterministic securities. Okay, so largely when we talk about the data center resiliency, we already went through the most of the contents: active, passive, multi-active. So here's a second aspect. If you remember the 4 challenges, right now we are moving to security. But nevertheless, let's be real quick on this one. So for security, we all know there's multiple kinds of different threats, right? Traditional attacks, they mainly based on some phishing emails, automatic attacks. Nowadays depends on ransomware, okay? Intelligent attacks, they mainly attack on your AI-driven vulnerabilities. They might be inject, malicious attack for your AI training. They might be tampering using AI to find the vulnerability of your system. Okay, next one, please. And we have to cope with that. Okay, secure steps in the general purpose era. There are many threats, but they are more to the determined side. So we already experienced them for many years. We're good at defending them. But in the AI era, we have to have new mindset. Okay, this is why later on we will talk a little bit about the security. of how we are using our solution to cope with that. Next one. Okay, this is again an illustration. So between 2010 was IT driven, mainly about traditional attacks. Okay, between 2010 and 2020, the data driven one, where we will have more and more big data and cloud computing in terms of have you build up the defense. This is much very efficient effective in terms of defending ransomware attacks, DDoS attacks, brute force attacks, this kind of thing. And after 2020, this is for the AI driven, okay, and the AI model security, the AI model enabled security, AI model based attacks are the new things that we are facing. Okay, so 3 stages, and now we are under the transition between the data driven to the AI driven. This is talking about how our solutions, the worldwide, people are using different kind of mechanisms to defend against threats. Okay, also another thing worth mentioning is the terminology that we're using. Previously, it's only about network security. Now it's all about cyber security, about cyberspace. Okay, not only about network, but about cyberspace, cyber security, covering the data-driven and AI-driven areas. Next one. Okay, and again, the regulation. So in the security, same as the uninterrupted service, there's regulation from different countries. And these regulations normally cover 3 different levels of aspects. It's either it's about general infrastructure, okay, or it's a security that's about important infrastructure or critical infrastructure. So this is also the level of severity. And different regulations, I mean, from China and other regions are quite complete, to be honest, in terms of the security measures. And yeah, similar to what we have seen previously. And I will not talk that in too much details about the compliance. Next one. Okay, top 4 courses. This is just to give you some insights. Okay, top 4 courses of cybersecurity incidents nowadays. This is the latest data from 2024. And what are the top 4? Can you imagine the top 4? The top 1 is actually the non-malicious human errors. Not really the hackers, like the malicious attack from outside, but from within. The non-malicious human errors caused by ourselves. Okay. The second one is ransomware, which we have to really be aware. Ransomware lately has been a big headache for a lot of enterprise because different from the traditional virus, they're coming to damage your data. Ransomware come to store your data, lock your data, and ask you for ransom. It's a business. Right? It's a crime business. So that's why nowadays ransomware is everywhere. And basically, if you got ransomware tag, most of people just choose to pay ransom because what can you do, right? Otherwise, your data will be leaked and your reputation will be damaged. And people don't want that, especially for large corporations. So ransomware, the second one. The third one is the third-party supply chain risks. What does this mean? Why in the security, they're also supply chain? Because nowadays in the software engineering, we are building large systems depending on different libraries and different communities, different developers. It's a jointly developed one. Okay, just give you an example. If you're doing AI research or in a data science research, mainly you are using some, let's say, some Python libraries. If you're like a developer running script code, some Python libraries, and it happened before, for example, for this the PyTorch or NumPy, the library tools, the scientific library tools, the hacker will just inject some virus into that. And every one of us, we're using that library to support our development, right? And that is doing the supply chain. That is one of your product. You're developing a product. Doing the supply chain, you're using a library, open source library, and that library has a virus. And then when you publish your application to your end users, it will be contaminated of the target system. So this is about supply chain risk. It happens more and more often. Like I mentioned, in the software engineering, also develop very, very complex. There's a supply chain over there. And the fourth one is the vulnerability exploits. So this is also a common one where we call the zero-day or end-day attacks, because every system, no matter how good it got designed, okay, we're talking about software system, whether it's from Huawei, it's from Google, or it's from Apple. Doesn't matter. Everyone has vulnerability. Because human design things, we cannot guarantee 100% there's no vulnerability or bug inside my code. It's just not yet discovered. Which is why all the the principal, the vendors, the brands, they're giving you, even you're using iPhone or Android, they're giving you update for the security patches. They realize the vulnerability and they do the patching before others take advantage of that. So this is about vulnerability. No one can gather there's no vulnerability. What the scenario is, we didn't discover the vulnerability faster enough. Okay, the hacker take advantage of vulnerability before us. So this is about vulnerability. And next one. Okay, let's have some more general things, not that much brainstorming stuff, and some numbers. Just look at the severity of security caused by the incidents. Okay, so this is from EY's 2023 Global Security Leadership Insight Study. The average annual loss for large enterprise, we're talking about enterprise with $1 billion revenue per year and more than 1,000 employees, those kind of large enterprise. The annual loss of them is almost $13 million because of the cybersecurity incidents. That's a big amount of money. And the average annual investment from those enterprises, how much was that? Only $3 million. So investing $3 million, which is better than nothing, but your loss is almost $13 million. And average cost of a data breach. So this is the secondary cost apart from the direct impact of the incident. Because of the data breach, you are paying almost $5 million. So if you got these two, it's almost 17 million from large enterprise annual loss from the security. And they only invest nearly 3 million. So we're seeing a large gap. This is also, we need to raise awareness of enterprise and organization. You need to invest more for the potential risk. You cannot be lazy and saying that I will be the lucky one, I will be the safe one. No one will be the safe one in today's environment of cybersecurity. Okay, next one. Okay, the same idea, probably quick. Just like what we call the area of triangle, remember? For security, the same. When there's an incident, you will survive at some stage and then you will recover. We will also monitor the area of triangle to determine the security resiliency of your data center. Okay, but here I'd like to mention an extra point. This is not about active or active passive. This is about within the security design of the data center. What are the aspects? We are talking about multi-layer. Okay, network border is a traditional one. Everyone has network border. Firewalls, right? For sure. If you build data center, you have firewall. But we also need to bring your attention to the host layer, where you will run EDR, end device. And for your end device, you also need to implement that to protect your host. And this host can be physical host, can also be virtualization of virtual host. Apart from that application, you need to have WAF to protect your application as well, the web-based application as well. And your data, the data storage, you also need to have protection mechanism. Either it's a ransomware detection or it's a snapshot scanning for any kind of potential threat or virus. Multi-layer of that. Okay, next one. And to break it down for the multi-layer, so the idea, I would go to the idea for security, multi-layer to have the resiliency. And again, we elaborate again, network border, endpoint device for the host level, okay, storage, production storage, one thing, backup storage, another. You have backup, and you have to have security measures on each of the storage. And potentially, we will also require for a high resilience data center to have isolation zone, a physical isolation zone, perform as an offline destination for data. Imagine you have an offline racks in your data center, namely, no outsider users or hackers can reach the offline part because this is completely offline. No plug into the internet or intranet at all. So this one, we will also recommend or like required by the DC resiliency to have these kind of layers. So again, we repeat, network border for sure you have endpoint security, production storage security, backup storage security, and isolation node. Okay, next one. And next one. This is the solution details. Okay, we try to be quick. Elastic adaptation. We go to availability, right? The third one. Next one. So elasticity. How we realize elasticity. There's, I will make it simple. Three major components. First, from access layer, the ELB and EIP. Okay, dynamic distribution of resources is necessary. Second, the intrinsic elasticity. This one, and with this, we mainly talk about general resource pooling. Okay, and third one, the facility flexibility. From your facility level, we get back to the facility. Until now, we talk about IT infrastructure, right? For the facility, you also have to be flexible in terms of power distribution, right? Of the single rack, whether it can be flexibly adapt to the traditional general purpose computing and the AI computing, the power, okay? And cooling, for example, is something, whether you are using air-cooled system or liquid cooling system, should be also elastically flexible. So three aspects. And next one. Okay, these are, we're going to talk about details of load balancing and EIP. Remember, I will not go to the detail because we have limited time. We just go through. Okay, next one. Okay, this is about, I mentioned the resource pooling, right? How you can have resource pooling? Very simple. You need to build virtualization or a public cloud. Okay, to cloudify your infrastructure, to make them resource pool, no longer based on the silo system and physical machines. Next one. And for the facility elasticity, we mentioned about elasticity. I just went to, okay, elastic space. You have this elasticity in the space of your data center, the room. Elasticity cooling, I will talk about. Air cooled, liquid cooled. Can you make them flexibly combined and with the elasticity behind that? This is important. Third one, elastic power supply. So previously, if you're talking about rack hosting a traditional general purpose computing, 6 kilowatt enough, well enough for a rack. But now, if we're talking about AI computing, we're mentioning about 50 to 100 kilowatt per rack. Okay, to support that. If you have, whether you have this elasticity, we also need to be ready for that. So this is about elasticity. Next one, the facility elasticity. Sorry. Okay, and extended elasticity. This is like the optional one. If you are running the center and edge management and also terminals, this one elasticity mainly give you a scenario. Okay, we're talking about maybe center training and a terminal for inference to better utilize, to leverage the latency and compute power. So for some edge data centers or some edge devices, you do not build a full stack data center, but at the same time, you still want to leverage a low latency. For example, autonomous driving, you're driving an autonomous like AI function car, and that car has to have its own small scale of computer as a data center for the inference, right? But the large training still happens within the central data center. So this is the thing that we want to leveraging the latency and performance in terms of resources. So this is the optional part. And the next one. Okay, last but not least, agentic AI. Okay, let's check about O&M. Finally, we went to the O&M. Next one. So evolving AI poses great challenge this infrastructure O&M. Okay, this is still we are elaborating the challenge. The complexity because of introducing AI to the data center, and also the insufficient hardware reliability because of introducing AI. This is the reason why if you look at the faulty rate of the NVIDIA compared to the traditional Intel, so NVIDIA NPUs, they have a much higher faulty ratio rate than the traditional Intel CPU. Okay, even though they're very, very good in terms of performance and supporting our AI training, but they tend to get defect much more than the CPU. So this is the aspect where in the AI scenario, the fault actually occurs much more often. Okay, and next one. Okay, the intelligent O&M, we finally got it here. I have emphasized again and again, we cannot neglect O&M for your resiliency, and you have to have intelligent O&M, which is AI-driven and AI-based, which has already been adopted by various entities across the world. For Microsoft, heavily engaged with AI-based O&M. AWS, heavily engaged. NVIDIA, let alone, okay, themselves doing their data center AI O&M. And ByteDance from China, the internet company, also heavily engaged in the AI O&M. Next one. So that's one of the solutions of providing the AI O&M, which is called this agentic enterprise ICT infra for DC. Okay, this is also a framework or the idea to provide you the AI native infrastructure. Okay, for the intelligent loss network, intelligent optical models, and the high precision data collection. By this, what we mean? This is a framework. Okay, I'm just talking about first one, AI native, meaning in the future, all the devices, the hardware components in your data center, they are also intelligently equipped with AI algorithm. For example, the intelligent optical module. We know the optical module you plug into the switch. That one is normally a passive device. Okay, but now we inject the controller inside that one, and will facilitate that single device can fault tolerant and rectify its own defects. So this is what we mean by AI driven, or sorry, the AI native, meaning all the traditionally the passive device inside of data center, we will also equip them with, for example, a small chip. Okay, a small chipset to facilitate them to be actively send their own health status and doing their own fault tolerance. Okay, this is the first. Autonomous O&M, the second one, using the AI to do the autonomous A&M. This is also AI very good at, to do the schematic planning for your data center with the input of your topology from your data center to provide the planning and design for the maintenance of your data center. Okay, the third one, the adaptive multi-agent. Okay, this is also the third aspect from AI. We are using agent-based, right? And as you can see here, basically the interaction between the different components inside of that, whether it's a ICT infrastructure, the smart operation platforms, okay, this here, the development platform, or the actual ICT infrastructure devices, okay. The AI serves here as a purpose for the multi-agent taking charge or getting information synergy from these different platforms. Okay, next one. Okay, this is our vision for the agentic AI O&M. Okay, again, we get back to the lights out. Okay, in order to have a lights out data center, which is our ultimate goal, we need to have AI O&M for these automatic capabilities. And aiming to do two things. One is increasing the MTBF. The other way is what we call reducing MTTR. Okay, so what does MTBF stand for? Any idea? This stands for the frequency between two faults, between two defects or two disasters. The time between the last incident and the second incident. Okay, we want to sorry, this is the time. We want to decrease that. Okay, this is the sorry about that. This is MTTR means that we need to reduce that. Okay, the mean time to recover. The mean time to recover MTTR. This means the mean time, the average time to the recovery. Basically means that between two faults, right? That's a fault and to recovery. We want to reducing that. Okay, this is the target we try to achieve using again O&M and two metrics. Remember MTTR, MTBF. Increasing MTBF but reducing MTTR. Okay, mean time to recover. And there's a couple of functionalities. This is actually provided by Huawei solution. If you were to check on our AI O&M. automatic risk resolution, automatic change verification, and automatic fault rectification. Remember, we also talked about these 3 factors where it is very, very important in terms of O&M. Okay, next one, please. And we will go to the last chapter. Okay, the last one, suggestions and guarantees for implementing resilient data centers. So we can wrap it up. We can make a summary. Let's go, next one. Suggestion 1 is commit to long-term investment in DC resilience. We have emphasized this one. Even though we give you short-term planning for application-based active-active, remember, the long-term speaking, we want to have you to get your data center to active-active, full-stack active-active, also on the data layer. And for the long term, that means apart from uninterrupted service, we also need to consider what? The security and the O&M, right? All these things, aspects you need to consider. So it's a long-term investment, and with a framework and a KPI set in your organization, long-term, do the drill, do the practice, and do the evaluation, dynamic. So it's a long-term investment. We have to be patient on this one. Okay, this is not something from day one, and this is always a joint effort from the users and from the solution provider. Okay, next one. The second is design the resilient DC with future-ready vision. This comes normally because of recent years' rapid development of AI. Any kind of infrastructure, no matter it's about maybe campus network or other kind of technology, you have to design them somewhat, forward-looking or future-oriented, because now the technology stack changes very rapid. We have to design them with the future-ready vision. Okay, I mentioned again, uncertainty in compute demand growth. You will never know. Maybe next year or 2 years later, with another boost of technology of AI, the computer resources will go crazy. Okay, so this is uncertain compute demand growth. Uncertain business continuity threshold. Okay, this is about continuity of the regulations or of all our user expectations on your services and products. Okay, maybe this year they still can tolerate, maybe you do some application upgrade and you told them the service will down for 6 hours, they are fine. Maybe every week they are fine with it. But with the development of technology, maybe next year they will make some noise about that. They will discard your service because they do not want any downtime during the upgrade, because others already achieved 0 downtime. Uncertainty and security threat proliferation is already mentioned a lot about security. So design your data center with a future-ready vision. Do not stick to the old technology. Okay, do not reference to those technology which is 5 years ago or 6 years ago or even 3 years ago. Always look to the future. Check the latest technology and design your data center's resiliency as futuristic as possible. Okay. Third one. Next. Third one is co-create a maturity model and define KPIs. As I mentioned, the frameworks were already given to you by Huawei. Right? We give you the framework. We give you the suggestions on maturity levels. Remember 5 levels and how you can evaluate your levels of data center, how you can do the classification of your application. But still, making a resilience data center is a systematic job. Requires a lot of consultancy and actual plan and design implementation and also potential migration. If we are talking about reconstruct active passive to active active, there will also be migration. So what we suggest is co-create. Always join together with you and as a vendor. Okay, we join together to co-create, to define, to design, to consult on your infrastructure, to make it a maturity model for yourself, tailored for yourself, and having the KPI to measure the performance. Either it's a personnel in your organization or it's the overall data center performance into the resilience. Design a KPI. This is always towards the modern management, this management topology, methodology, right? You have to create something as a fixed KPI to measure the performance of the resilience. And this one will encourage you and us to jointly create on this one. Second, third. Okay. this will be the last one. Thank you everyone for bearing with me. I try not to take too much time. Okay, this will be the last one. 4 guarantees for implementing resilient disease. 4 guarantees. When you are doing the implementation, we use this one as a wrap up for today's session. Okay, remember 4 guarantees. Okay. First, organization and process guarantee. Okay, this lays the foundation. This is about the management. We just talked about it. Maturity model, do the classification, having the KPI. Building up the consensus in the organization, and also build up the culture of everyone pay attention and value about the resilience of data center. This is the foundation within the organization. Okay. Second, the architecture and solution design, technology, how we design the active-active, how we design the security with multi-layers, right? How we can incorporate AI, O&Ms, so on and so forth. This is about design, okay? O&M integration. Again, this is emphasis of O&M. I already mentioned AI O&M.